All right, so let's address the last page. So I need you to find angle A. I need you to find side A, and I need you to find side C. There's different ways to approach this, but probably what I would do is I would find angle A first. So I would go 90 minus 39, which is 51 degrees. Now you can use the 51 degrees to get the other sides, but for me, I feel like I'm just going to stick with the 39. So when I look at the 39 to the 6, that's opposite. This is adjacent, and that is hypotenuse. So I think when I think opposite, I think sine. So sine of 39 equals 6 over c, and I will find c that way. I'm also going to do tan, so I'll do tan of 39 equals 6 over a. Okay? And if you want to, some of you might think it's easier to do the 51 here because that's adjacent, or I guess this would actually be easier. So let's stick with that. But whatever you want to do, as long as we get the same answers. And let's make sure that's degrees. So if I'm going to solve this, I multiply both sides by c. And then I'm left with c sine 39 equals 6. And then I divide by sine 39, divide by sine 39. So in my calculator, I'm going to go 6 divided by sine 39, and I get 953. So since it doesn't tell me how to round, I'll just stick with the hundredths, unless it specifically tells me. And now I'm going to do the same thing here. I notice there's a pattern, so I'm just going to go 6 divided by tan 39. If you want to jump straight to the step, you can, but you need to show me some work that shows me what you did in the calculator and that you didn't copy off your friend. Okay, so let's go 6 divided by tan 39, and I get 741. All right, so I've got all of my answers, and now I need to figure out what I did wrong. Does anybody notice what I did? Because I do. This was A, but I put it in for C. And this is A, and I put it in for C. And you know how I noticed that? Was this, the hypotenuse always needs to be the longest length. So when I did a quick check, 6, 741, and 953, the hypotenuse always needs to be the longest. Now, if I have time at the end to check, I'll use the Pythagorean theorem. So I'll go 6 squared plus 741 squared equals 953 squared. Now, it's not going to be perfect, but it will be close. I know that this is 36. 7.41, it's just easier for me to do that. 7.41 squared is 54.91. And then 9.53 squared is 90.82. So I'm going to add these two and see if it's close. 36 plus 54.91, and it's 90.91. The reason it's not perfect is because we estimated. But I think you can see that I got it the right answer. Okay? So always check if you can. This problem is the same thing as this problem. So I do the same thing. Angle Y. Remember, the capitalized are the angles, so let me make sure I capitalize that. Angle Y, side X, and side Y. Okay, so I know this angle because I'm going to go 90 minus 51. Which is 39 degrees. Okay. And then I'm just going to stick with what I have here. So I look, this is my hypotenuse, this is my opposite, and this is my adjacent. So I'm going to find sine first. So I go sine of 51 equals x over 9. And then I'm going to do the adjacent one, which is cosine of 51 degrees equals y over 9. This one's actually easier than the previous because all I have to do is multiply by 9 on both sides. So in my calculator, I'm going to go 9 sine 51. So 9 sine 51. And round to the nearest hundredth is 699. Now I'm going to be smart and make sure that I do the right one. And then 9 cosine 51, and I get 566. The good thing is my hypotenuse is my longest length. And then I could check. So I can go 699 squared. So 699 squared plus 566 squared equals 9 squared. I know 9 squared is 81, so I'll go 699 squared. I could just do 7, but whatever. 4886. 5.66 squared is 32.03. Add that to 48.86, and it's 889. So it's really close to 81, so I probably did fine. The only way I'll make a mistake is if I put x for y and y for x. All right, find the missing lengths of the special triangles. So I know this is 30, and that's 60. Now remember, I always use my blue pen. Would always, oops, I'm not doing awesome today. 30, 60. So 30, what's across from that is a 1. What's across from a 60 is a rad 3, and what's across from the 90 is 2. So what I need to figure out is 9 times what gives me rad 3, okay? Or rad 3 times what gives me 9. Some of you know that it's 3 rad 3, because rad 3 times rad 3 is 3, times 3 is 9. But let's say you didn't know that. What you're doing is you're figuring out rad 3 times what equals 9, and when we don't know something, we call it x. Divide by rad 3. Rad 3 is 9 rad 3 over 3, which is 3 rad 3. You don't need to do that work if you can just see it, honestly. Times 3 rad 3 times 3 rad 3. So, on the test, what you're going to do is length I is 3 rad 3, because what's across from the I. Length R, it's always lowercase, is 2 times 3, which is 6 rad 3. So those are my missing lengths. All right, last one is a 45, 90. So that's 1, 1, rad 2. The game is the same, so I could go rad 2 times what equals 10. When we don't know something, we call it x. Divide by rad 2. Rad 2, which is 10 rad 2 over 2, which is 5 rad 2. Now, some of you just know that the goal is to eliminate the radical. So that means we go rad 2 times rad 2 is 2, times 5 is 10. So times 5 rad 2 times 5 rad 2. And the great thing about a 45, 90 is that whatever this length is, this length is. And you'll notice in this one, I didn't give you the letters, so you just write down the lengths right there. All right. Find the exact value of sine, cosine, and tan of negative 135. Well, what I don't like about negative 135 is it's in negative, and you know I like things positive. So I'm going to find the coterminal. So I'm going to go negative 135 plus 360. I think it's 225, yep. Okay, let me draw this. 225 ends up in the third quadrant. So this is 225. This is 180, which means finding the reference angle. So you're going to go 225 minus 180 is 45 degrees. Then you remember the ratios. The ratios are negative 1, rad 2. So if I'm going to find sine of negative 135, which is actually 225, and I'm going to go cosine of 225, and I'm going to go tan of 225. Now be careful, because I know you're going to want to write 45, but technically it is 225 degrees. So you need to make sure you write that. If you write sine of 45, it's actually incorrect, because then that's in the first quadrant, and then this one and this one would both be positive. All right, sine is opposite over hypotenuse, so if it helps, do the labeling, especially if you're stressed out during a test. So negative 1 over rad 2 is negative rad 2 over 2. If you want to, you can go straight to this step. I'm okay with you doing this in your head. Just show me some work. And then cosine is adjacent over hypotenuse. It's the same thing. That's the nice thing about a 45. But you want to be careful, because I want to point out that they're not always going to be the same. Because if this was in this quadrant and that was negative 1, rad 2, the sine would be rad 2 over 2, but the cosine would be negative rad 2 over 2. So be a little careful about that. All right, tan is opposite over adjacent, and negative 1 over negative 1 is 1. Okay, so make sure you show me enough work, and good luck on your test.